How's it going, everyone? Welcome. Elvir Gonzalez. And let's take a look now at the chapter 2, in illustrating the lexical scope, where in this video, I want to explore is now what the lexical scope is and how do we get here and why it is important for us to understand this. So when it comes to now read particular pieces of codes here and there for any other company, especially in JavaScript for the web, where now if we want to understand now what the scope and closures is at the end of the day, it's just not something that is magical. It's a series of logical steps that's going on that allow us is to, or that unlocks is several model patterns here, a way to organize our code. And I want to make an emphasis here because when I look, just to make a quick recap of how do we get here. So in the first book, written by Cal Simpson, where he described is not only is the intrinsic nature of the language and all of these low-level features, but also the things that are around to it, right? So first we look at what is JavaScript, who makes JavaScript, why the name of JavaScript, who oversees the technical spec, who owns now the legal trademark of this, and for example, with the TC39, which is the commit that oversees that this language and all of the features now are backward compatible, so they don't break the web. And because they now have different stage from 0 to 4, 5 stage in which now a champion or a proposal will go through a series of this page all and works all the way up onto the top. Okay, so we also look at why for sometimes there is a very interesting topic of this mushgate, which is something that despite that the TC39 makes its best effort to set the spec for all of these JavaScript implementations, sometimes they have to draw back it and to redraw some of those spec. So these implementations or the implementators, whether it is any of these JavaScript engines, whether it's Chakra or V8 or JavaScript Core from Safari, amongst others, right? The only reality that matters is the web. Despite that you can now run these JavaScript engines in different environments, whether it's on the client, on the server, on robots, on light bulbs, you name it. Okay, so also we look at how can we now guarantee that certain features that are not still available on JavaScript are still being used, or we can have access to by defining is this polyfill, which is sometimes defined by this champion at the TC39. Okay, and how can we actually work with that? Also, to understand that not all JavaScript environments are strict, or they strict follow the ECMAScript spec. And a good example of that is the console on the browser console. So there is a particular example of how you can actually make that happen. One of them is when we use a strict, something that we're gonna see that later as well. But also is a different approach when it comes to solve specific problems. So when the problems are computation or calculation, now how functional programming allow us is to use all of this pattern and make our code much more easy to read and to maintain. And the other is when we care about is collaboration or cooperation, so object-oriented programming is the way to go. As well as the procedural. And because there is a concern of JavaScript engines that they are not fast enough. We also look at what is ASM.js and WebAssembly, and why now WebAssembly is this universal compiler target that allows us is to have, by having a particular application written in Rust, Java, Python, or any other programming language, compile that into this intermediary representation or this code that look like an assembly, all right, and so it now it is ready for executing in any of these WAS environments. Okay, so also we look at what the strict mode is, why it is important, and now serving the JavaScript knowledge, all right, at least the a broad stroke here. So for example, what a program is, how JavaScript sees a programs, how can we now write our programs, what are the most important units in our programs, which is values, and what kind of values we can have in the language, whether it's primitive and an object, and how now some primitives actually follow a specific spec, for example, strings and numbers. And in the case of objects, we have now is this different way of how can we organize our values, whether it is as an array or as a hash or a function. And functions also is a value here. So how can we now is use those values, whether it's a literal or held inside of a container known as variables? How can we declare those variables? How can we use them? What are the different syntax forms that we can have in the language? And how can we also is look at the different way of defining variables, all right? Not only with var, let, and const, but also is with the functions definition, as well as the formal parameters inside of the function, right? And also other places as well. So for example, with the for of loops, in exploring is the way how now JavaScript see this function, what is the role of this function, whether it's a procedure or a mathematical strict definition what a function is, and also now how we can is do some operation with this value. So for example, how can we compare those values? How can we transform this value? What is now what it means to compare value, what now JavaScript understand by comparison, right? So this referential equality, and how now what are the series of steps in order to transform one variable to another, right? And the other is how can we now organize our code as a function, as a class, as a or as a model, okay? And this is just serving the surface, serving JavaScript, serving the surface of JavaScript, the things that we need to know. And also is the lower level features, which is the iterations. Why do we even care about the iteration? What is this iterator protocol and the iterables? And another is what are the features that function has? So for example is this value or the closure, and also another property that object has. So for example, is the object prototype change. So all of this, just to describe now this huge overview of JavaScript. And in order to understand now for sure and once and for all is these low level features like this enclosure, we need to understand is what a closure is and what a scope is here. So this is why we're actually reading this. So as a way to understand now this scope, okay, first we need to make a quick recap. Since now variables are the most important variable, since variables are the most important tool that we have in our programs, okay, so we need to understand now, for example, how JavaScript is allows to have access to variables in a particular statement. How does JavaScript know that? Or how JavaScript now knows how variables with the same name, so how JavaScript handles variable with the same name, okay? Well, this is pretty quite interesting because as we look and as we explore this kind of this particular topic, which is part of the scope, we need to understand now is a little bit of theory, the compiler theory. So understanding now what a compile and what an interpreted is, because since variables is one of the most important features in any programming language, and how we define as an author variables, functions, and block, and how they relate each other, all of them are determined is by the scope at before it is execution. So this scope that is now is not being affected by runtime conditions after the scope structure is established before the code is executed. This is not going to be affected at runtime. So because of that, and since functions are values in our programs, and we can hold now variables inside of our functions, we need to understand now how these functions are processed, or the scope structure exactly. Since now variables can be defined inside of the functions, and functions are now values in JavaScript, so the scope structure resulting from this function, which remains the same after the compilation phase, in runtime, this doesn't change. So anytime that we call this function with this scope structure, all right, it will maintain that no matter which part of our function we call it, okay? And this is known as closure. This is pretty interesting because now this lay out the fundamental of now what this is compilation and interpretation means. So we got the compilation, we got the interpretation. So the only difference, so both of them are process that defines a set of instructions of how now this source of text is going to be converted into human into machine readable code. Okay, so uh, because of that, in that at the end of the day, these compilations and interpretations vary is in the way how this is being processed. So compilation is made of the compiler theory. In a classical compiler theory, you have now is this um, three phases. You have the tokenizing or the lexing, which is going to now take your source code and convert that into meaningful tokens for the language to uh, a, put it that like in a like a marbles in a buckets here, right? So it's going to create all of these particular tokens that are meaningful for the language. So in our case, this is pretty much like any particular if words that have meaning in our language, whether it's in English or in Spanish or in Chinese or in French, German, Swahili, Portuguese, you name it. Okay, if that doesn't make sense, so we don't consider that as a token. you know, so this is similar to what we have in the language. So the subtle difference between the token and or the tokenization and the lexing is that there is now how the tokenizer is going to evaluate the is going to decide if this particular token is a different token or is belongs to another token. This is the difference between the tokenization or the lexing, right? So once this string of tokens has been created, well, we now have is the parsing phase. So now that we have all of these strings of tokens, when it comes to parsing, to generate is now this abstract syntax tree, which is this internal representation of the grammatical structure of your program. Okay, then on the code generation, this is when your abstract syntax tree is now converted into binary code that is very specific to the platform, the OS, and even the language that is being used. Okay, so this is the three phase of the compiler in the classic compiler theory. Again, because JavaScript is an scripted language and it needs to now process all of these statements in milliseconds, so it doesn't have any build step, all right, to do that. So this is when it required to go to some certain hacks here. So for example, like just-in-time compilation, and because of this, since JavaScript is is a compiled language in the sense of how it process or how it analyzes the code, not its distribution. And it is because the behavior that we can look at the language in terms of how it handles is early errors. Okay, so for example is syntax errors. The other is this exactly, for example, syntax error. The other is that early errors, so for example is if you have the same name, if a function have the same name parameters and use a string inside of that. Let me actually put it that test, because you might say, hey, you are hallucinating. Say, hey, say something, you know. You can say, hey, Here I want to define is this, say something, okay, and I want to get is the word and word, right? And if I use now this strict mode, okay, to say, hey, what need to put here, and if I say strict mode, say, hey, console log of the, hey, let me do this way. I'm using this template string to do this. Say, hey, sorry, hey, word followed by word by another word, you know, and then you say, hey, say something like this. You say, hey, ¿qué tal? Right? So here we're gonna say, we're gonna throw you this, right? Say, hey, duplicate parameter name not allowed in this context. However, if you don't pass is this, and then you call this, that's right. Oops. Now it showed this, you know, so to avoid this funny behaviors that it has. So the strict mode allows us is to say, hey, no, don't get too fancy here, and now throw an error here, right? Early errors, and you can take a look at the ECMA spec to check that for, known as static semantics, right? And the other is now hosting, and how now hosting works. So for the case of so for example, here in hosting, you got is this one. So I was going to define now, for example, is function. So function here to say, again, say something, okay, and I'm going to receive now a parameter to say, hey, this is now var say something. Here I'm going to define is this hello, okay, hi. Quite redundant, I know. Or you can say salute. So, and then you can define something like this. Hey, this is now a block, all right, where now salute, it'll be is hola, right? And then you're gonna say, hey, let salute be is hola, ¿qué tal? Right? And then try to console log this one. So for those who are quite familiar with, you might say, hey, well, like this, and at the time when you say something, right, say something. So by the time you call this, it say, hey, can I have access to salute before initialization? And it's because you might think that this salute is something that is assigned to this. But the reality, the truth is that because now it belongs to a block, and we are using is a let to define as a variable salute. Now here is handling is this hosting or this closure here, particularly this scope here. So because of this example, all right, on the chapter 1, that to me was quite interesting, very interesting, Very, very, very interesting. So say something like this. Okay. So this is now behaviors that's telling the language that act as a parsing compiled language rather than in an interpreted language. Okay. uh, and also is well, why do we even care about this, about the assignment here? That because that's the question here. Why do we even care about is the assignment? uh, because now, in the case of the programming, in the case of JavaScript, when it comes to define what is the place where you're going to define if this is the left assignment or right hand assignment, and in our case we're going to use is source and targets. Okay, here we're looking is at different places where we can identify is the target of an assignment here. This is clearly one of them. This is clearly another one. This is clearly another one. Okay, when you assigning is now a variable to this. Okay, student is now the target of this assignment. Okay. And next student is another target of this assignment. So the point of this of looking is at the target and at the source. Okay, to me it was not quite, I don't quite grasp it here, because this is something that we're going to see that in the other chapter here. But we look at some changes that we can do to modify the scope of our application. So for example, the scope here, and how this might be a bad idea. Using is the eval. Don't do that. Don't do that. So here we show now that the lexical scope, okay, we have demonstrated that JavaScript code is determined at compile time, right? So somehow this lexical, okay, this is the JavaScript scope is determined at, okay. So with this example, we have determined that JavaScript now, so we have demonstrated that JavaScript scope is determined at compile time, not an execution time. And this kind of a scope is known as lexical. And lexical is associated with the lexing stage of compilation. Hey, is this token belongs to this another token? Or is a different token, as discussed early in this chapter. To narrow this chapter down to a useful conclusion, the key idea of the lexical scope is that it's controlled entirely by the placement of the function, block, and variables declaration in relation to another. So the function, the var, and the blocks, they are associated or controlled entirely for at where are they in the programs in relate to each other. So if you place a variable declaration instead of a function, the compiler handles this declaration as it is parsing the function. If you play a variable declaration instead of a function, the compiler handles this declaration as it is parsing the function and associates the declaration with the function scope. If a variable block, for example, in this with hosting, is this with hosting? Is this with hosting? If we define, oh my god, that's fucking. If we define, Jesus, I don't know if I'm gonna die here. If we define if we define, or if we place a variable inside of a function, the compiler handles this declaration as it is parsing the function and associate that declaration within the function scope. If a variable block scopes declare let and const like this, so if a variable is block scope declare in the let and the const, then it is associated near it enclosing block scopes rather than it is enclosing function as it var. And furthermore, a reference, whether it's a target of the sort role for a variable, the reference for a variable must be resolved as coming from one of these scope that are lexical available to it. Otherwise, the variable is said to be undeclared, which is usually resulting in an error. If the variable is not declared in the current scope, the next outer and closing scope will be consulted. Exactly. So, furthermore, in order to resolve if a variable, a reference variable, must be resolved as coming from one of these scope, from one of the scope that are lexically available. So otherwise, the variable is said to be undeclared. So if a variable is not declared in the current scope, all right, the next outer and closing scope will be consulted. And this process of stepping out of the next, stepping out the one level of the scope nesting continues until a matching variable declaration can be found or not. And it is important to note that the compilation doesn't actually do anything in terms of reserving memory for scope or variables. None of the program has been executed yet. Instead, the compilations create somehow like a map. Okay? It creates now a map of all the lexical scope. And this lexical scope, it is whether it's a function, whether it's a block, whether it's so now at the compilation phase, a map of this lexical scope is created. Okay, whether it's for function, for global scope, function, and block scope, and layouts what the program will need while it is executed. You can think of this plan as inserted code for use at runtime, which define all the scope, aka lexical environments, and register all the identifier variables for each scope. So you can think of this as a plan. You can think of this plan as inserted code for use at runtime. Okay, this is the code, this is the map that I'm going to insert at runtime. If this is true, which define all scope, aka lexical environments. If I go to ECMAScript here to define the lexical environment here, which is something that I don't, lexical or environments here, environment records, environment records, environment records, environment records, environment records, environment records. Okay. Environment records, lexical environments. But here you're talking is the environment records. Declarative environment records, a function environment records, a model environment record, object environment record, which is used to define the effect of ECMAScript elements such as width, and global environment record. It is used for script global declaration. It does not have an outer environment. Its outer environment is null. hmm And it's here where this is happening. Environment records can be thought of as existing in a simple object-oriented hierarchy where environment record is an abstract class with three concrete subclasses: declarative environment records, object environment records, and global environment records. Function environment records and model environment records are subclasses of declarative environment record, but they can be think like them. So this environment record abstract class include the abstract specification methods in table 14, and this abstract method has distinct concrete algorithm for which of these concrete subclasses. So you have now has binding. So all of these methods, hey, has binding. Determining if an environment record has a binding of a string value. Create mutable binding. Creating mutable binding. Initialize binding. Set mutable bindings. Set mutable bindings. Get bindings value. Delete binding. Has this binding. Has super binding with base objects. But this is all of the method that this environment record that can be is either one of these classes, okay, where this environment record, I think that this is how it's going to now store, it's going to associate it as identifier to specific variables and functions. So environment record is an specification type used to define the association. So this is a special record used to define the association of identifier to specific variables and functions. Okay, so environment records. So on the environment record, which is how now the identifier to specific variables and functions are based upon the lexical nexting structure of ECMAScript code. Usually an environment record is associated with some specific syntactic structure of ECMAScript code, such as functions declaration, a block statement, or a catch clause, or try statement. Such as function declaration, a block statement, or a catch. But usually an environment record is associated with some specific syntactic structure. Holy hell. Go, such as functions declaration, a block statement, or a catch clause of a okay. So anytime that you have now the function declaration, a block declaration, or a catch, now an environment record, which is how the identifier is resolved to variables and functions, has. Each time such code is evaluated, a new environment record and is created to record the identifier bindings that are created by that code. But this is usually every environment record has an outer field which is either null or a reference to the outer environment records. This is used to model the logic nesting of environment record values. The outer reference of an inner the outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment records. An environment record may serve as the outer environment. An environment record may serve as the outer environment for multiple inner So an environment record may serve as the outer environment, for multiple inner environment records. Okay. For example, if a function declaration contains two nested functions declarations, then the environment record of each of the nested function will have its outer environment records, will have their outer environment records, the environment record of the current evaluation of the surrounding function. And environment records are purely specification mechanism and not need to correspond to any specific artifact of an ECMAScript implementation. It is impossible for an ECMAScript programs to directly access or manipulate such values. Holy moly. So this is describing here is the scope change, or the scope surroundings here. Holy hell. Executable code and execution context. And all of these are records. The other is the object environment records. It's associated with an object called is this binding. An object environment record is associated with an object called it is binding objects. An object record binds a set of string identifier names and directly correspond to the property names, and it is binding. So you now have this. The other is a function environment record. It's a declarative environment record that is used to represent the top level of a function. And if the function is not an arrow function, provide a this binding. If a function is not an arrow function, a reference and reference super. If a function environment record also contains the state of this, and this is what it contains, this value, an ECMAScript language value, and the this binding status, lexical uninitialized and or uninitialized, in the function object, an ECMAScript function object, this function object whose invocation causes these environment records to be created. So when the function object is invoked, this environment record is created. And the new target is a second structure. And you have all of this. Bind this value has super global environment records. Okay. That has only this object records, global this, and declarative records. And declarative record that can be either is contains binding for all declaration in global code for the associated realm. A realm consists of a set of intrinsic objects, an ECMAScript global environment, and all the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resource. A realm is represented in this specification as the realm record, with this field specified in the table. So this is like an object that contains this intrinsic agent significant. This realm that contains all of these objects, intrinsics, so intrinsic value used by this code, global object, global M, template, and host defined. Okay, so here you're talking about is now the realm, okay, which is like an object that is made of this, okay, that is made of a set of intrinsic objects and a global script and a global environment, and all the ECMAScript code that is loaded within the scope. Okay, code exec for contains binding for all declaration in the global code for the associated realm code except for function declarations, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. So this is model environment records and the environment record operations, private records, realms, and execution context. So it means that this is not handling. So this is like a map. So this is like a map that is being defined. Okay, so this is now, so compilations create a map of all the lexical scope that lay out what program we need while it executes. You can think of this plan as inserted code for use at runtime. Hey, I'm going to define at compilation time all of this scope, all of these environment records for functions, block, and variables, okay? And I'm going to then insert that at runtime, which define all the scope, lexical environments, and register all the identifier variables on each scope. In other words, while scope are identified during compilation, they are not actually created until runtime. While scope are identified during compilations, they are not actually created until runtime. Each time a scope needs to run. In the next chapter, we'll sketch out the conceptual foundations of lexical scope, which is what we're talking about here with this particular example of marble buckets and bubbles, and how to try to simplify this. And also another analogy is a conversation among friends, when you have now the engine, the compiler, and the scope manager. And now first the scope manager, okay, and first the compiler talk to the scope manager to figuring out and to create this map of variables. So I do find that's quite interesting. I do find that's quite interesting. Compiler and global scope manager and compiler. So the conversation is a question and answer exchange where compiler, exactly. And then once the compiler creates a map of a scope, then is when the engine kicks, is when the execution of the program kicks in. That is talking about now is the reference. That is talking about here is the reference. Hey, is this variable? I got a target reference of this variable, or a source variable, or a source reference. Okay. And what happened with the nested scope here? So when in the nested scope, so when a lookup fails, there are now some not that funny behavior here. So for example, define mess, and the other is the global what. For example, trying to access to this accidental global variables and continue the conversation. So all of this is just because in order to understand now what these conversations, in order to understand now the lexical scope here, and how now JavaScript figuring out is if two variables, how to handle variables with the same name, or what variables do I have access at this particular statement, and why it is important to understand now the compilation and the interpretation, the classical theory, and so on and so forth, as well as the step of the compilation and what is the observable behaviors that happen in JavaScript when it comes to uh, uh, the observable behaviors in JavaScript for errors, from certain kind of errors. So for example, syntax errors, early errors, as well as the um, hosting. Okay, and why we explore about the assignment of a variable. Okay, whether it's on the target and the source, which is something that we're gonna see that here would set now as the with which now opens up is the understanding with this metaphor. With setting up this metaphor here with the conversation that now the compiler and the scope manager has initially when it comes to create this map of all of these um, uh, variables reference or identifiers, and then at the execution is that how it's going to determine now those reference and assign that to the value, right? How it's going to determine is the reference and the variables, so they can now evaluate that statement here. So when it evaluate this statement here, okay. So before continuing, go find some code in one of your projects to run through this conversation. Seriously, actually speak out loud, find a friend and practice each role with them. If either of you find yourself confusing or tripping up, spend more time reviewing this material. As we move up to the next author's chapter, we'll explore how lexical scope and programs are connected in a change, which is the scope change. Lookup is mostly conceptual and shadowing. And the concept of shadowing, global unshadowing tricks. Copying is not accessing. Illegal shadowing. And function node scope here and so on and so forth. Okay, so that'll be all for this video. Take care. Bye bye.